Hello everyone, welcome again to my channel. So, guys, before I start my video for today, let me tell you one thing. The name of my channel is changed. Instead of Chemistry Demystified, it's now Let's Chem. The reason for this is there are already 2 to 3 YouTube channels with the same name, Chemistry Demystified. So I thought of changing the name. So guys, as I told you in the last video, that today's topic for us will be inspection method. What is inspection method? Where do we use it? How it is beneficial for us? Everything I will let you know in this video. Before that, there are some basic terminologies that you should be aware about, or basic concept that you should know about before we start this inspection method. One of those concept is called as Hess's law. Of constant heat submission. And I hope if you would have read the basics of thermodynamics of class 11th, even in NCERT, very properly this concept has been given. So I will just brief you about this concept, what it says. There is one reaction happening in the order A gives B, such that the enthalpy change of the reaction is delta RH. So let's say this reaction where A is the reactant and B is the product can happen in another way, where A first goes to C, then C goes to D, and then D goes to B. And let's say the enthalpy change that happens when A goes to C is delta H1. The enthalpy change of the reaction which happens when C goes to D is delta H2, and from D to B is delta H3. So Hess's law states that the net enthalpy change of a given chemical reaction is equal to the sum of enthalpy change of the intermediate steps. Intermediate steps. What is the meaning of the word intermediate steps? It means the sub steps. For example, here A to C, C to D, D to B. What are these? Intermediate steps. So if we apply Hess's law here, we can write that delta RH is equals to delta H1 plus delta H2 plus delta H3. But this is only when there are 3 substeps or 3 intermediate steps, right? There can be 4 intermediate steps, 5 intermediate steps, there can be n intermediate steps. So mathematically, this equation we can also write as delta RH equals to summation of I equals to 1 to n delta IH. Okay, summation of I equals to 1 to n delta IH, where I value can run from 1 to n, where n here, what is the meaning of n? N stands for total intermediate steps. So if the n value is, let's say, 5, so delta RH will be delta plus 2 plus 3 plus 4 plus 5. So this will simplify the solution for us. Okay, this law, that is Hess's law of constant heat summation, is somewhat similar to the concept of Kirchhoff's law. That you would have read in current and electricity in physics. So there is a node, let's say A, not exactly the same, but yes, comparatively the same. So what we can see is from B to A, when current is going, that is current I. Okay, and after going to this node A, what we call this node at this point as node, this current gets distributed in different branches such that the current moving in this direction is I1, this direction is I2, this direction is I3, this direction is I4, and this direction is I5. So guys, can we say that I is equals to I1 plus I2 plus I3 plus I4 plus I5? This is what it called as Kirchhoff's law. So using this Hess's law, what exactly can we find? We can find the net enthalpy change of the reaction, or we can also calculate any one of the intermediate steps enthalpy. Okay, we can also calculate any one of the intermediate steps enthalpy. Now, inspection method is anyhow a shortcut method, but this method that I am telling you will help you in your school exams as well as in your competitive exams. I'm not saying this is the best method. You might be aware about some other methods as well, but this is the most apt method according to me. Without wasting any time, you can solve questions related to thermochemistry of what type, that I will let you know. Okay, so I hope basic introduction is done. I'm not getting into the depth of thermodynamics. We'll do that in later chapters or in later videos once we are actually focusing on the complete thermodynamics chapter. Now it's only about the topic inspection method. So guys, I have written some numericals here. If you can see, on these numericals I will show you how to apply inspection method one by one, and after finding the answer I will also tell you how to check whether inspection method is correct or not. Whenever you are reading any method, from every angle you should check whether it is genuine or not. If you ask me, is inspection method having any shortcomings? Yes, it does have. There are some numericals where even if you apply inspection method, you don't get the final answer. Even those numericals also I will take, but not in this video. This video is only about those numericals which can be solved using inspection method. Okay, so let's see the first question that we are having here. This question says that the combustion of 1 mole of benzene takes place at 298 Kelvin and 1 atmospheric pressure. After combustion, carbon dioxide and H2O are produced and 3,267 kilojoule of heat is liberated. So here only we'll write exo. Liberated means it goes out of the system. Calculate the standard enthalpy of formation of benzene, The standard enthalpy of formation of carbon dioxide and water is given respectively. So guys, in the inspection method, the first thing is to write down the chemical reactions. Now see, chemical reactions might be given to you or chemical reactions might not be given to you. It depends upon the nature of the numerical. If chemical reactions are given, then it's fine. But if chemical reactions are not given, you have to write the chemical reactions on your own depending upon the previous concept of thermodynamics that you have. And if you don't know how to write chemical reactions from statements, thermodynamics becomes a bit tough. So let me write down the first reaction here, which says that after combustion of benzene is C6H6L plus O2 gas gives carbon dioxide gas plus H2O liquid. Now I have to balance the reaction. 6 carbon, hydrogen is balanced, 12 plus 15 by 2. If you can see, even oxygen is balanced. Always your aim should be to write a balanced chemical reaction, because in thermodynamics, you know, the problem is whichever terms we are using in thermodynamics, especially in thermochemistry, are extensive properties. Like delta H is an extensive property, or it's an extensive term, which means that it depends upon the mass of the system. So it matters if you write 1 mole or 2 mole, the difference is there actually. Because if you write 1 mole, it is always defined for per mole, right? So if you write 2 moles, the data has to be multiplied with 2. So that thing you have to keep in mind. So here what I'm doing is I'm taking the first reaction value as delta H1. Okay, because everywhere standard is mentioned, so I will just put the value as naught. Even if you are not putting the value as naught, it's fine, but it's a convention that you should follow. So this value is given how much? This is given as minus 3267 kilojoule. Second reaction is also given, that is the standard enthalpy of formation of carbon dioxide. So I'll write down that reaction here. Third reaction, standard enthalpy of formation of water. Now 3 reactions are already given to us, but the 4th reaction is not given. Like in none of the reactions were given. What I mean to say is for 3 reactions, value of delta H were given. The 4th reaction should be mostly that reaction whose value you have to calculate. There's no any such convention. I'm just giving you an idea. You can take the first reaction also whose value has to be calculated. But I always take it as the 4th reaction or the last reaction. So what are they asking us to find? The standard enthalpy of formation of benzene. So I hope you are aware that benzene is made up of carbon and hydrogen. So standard enthalpy of formation of any substance is from its constituent elements. So 6 carbon solid graphite. I hope you understand why I am writing graphite, because it's a more stable allotrope of carbon as compared to diamond. And C60 Buckminster fullerene plus 3H2 gas gives C6H6 liquid delta H4 naught we don't know, so we need to calculate. Okay, now see how fast we can solve this. I'll directly write the solution here, just keep an eye on it. You have to go step by step. First you have to see the reactants. Okay, first reactant I see and put a tick mark on that, carbon. So carbon, where do I see carbon? Out of reaction 1, 2 and 3 we have to find out where do I see carbon. So carbon I see in equation 2. So I will write here equation 2. How many moles of carbon do you need? 6. How many moles of carbon are there? 1. So how to make it 6 moles here? So you have to multiply it with 6. Understood? Second thing you have to check is you need carbon in the fourth reaction on reactant side, and carbon in the second reaction is also on reactant side. So if side is okay, means the side that you need already that element or molecule is present on the same side, then no need to do any changes. But if you have to reverse the side, then you have to multiply it with -1. But here, since the side is okay, even if I multiply with 1, that doesn't changes anything. So I'm not going to multiply it with anything. So for me, carbon is done. Next thing that will come into picture here is plus hydrogen. Now hydrogen I see in the third reaction. How many moles of hydrogen is required? 3. I have only 1 mole. So again I will multiply it with 3. Side is okay. Reactant side, plus the last thing that is there in this reaction is C6H6, which is the product. Where do I see this? I can see this in the first reaction. So first reaction, number of moles are okay this time, but side is not okay. It is on the reactant side, but I need it on the product side, so I'll multiply it with -1. Now for whatever reactions you have multiplied, you have to multiply directly their values with the number. For example 2, so minus 393.5 into 6 plus third reaction into 3, minus 285.83 into 3 plus first reaction minus 3267 into -1. This is your answer, kilojoule. Okay, so you can solve it. Multiplication and addition will not be a tough task for you. Okay, so you can easily solve this. For example, let's see this. This will come as plus 3267 minus, so if you do guys, 393.5 into 6, it comes as 2361, and minus 285.83 into 3 comes as 857.49, and if you do the final thing, it comes as plus 3267 minus 3218.49, which comes as, I hope I'm doing the correct maths, minus 3267, which comes as 48.51 kilojoule, which comes as how much? 48.51 kilojoule. So any idea what did I do here? I just took the corresponding values, multiplied it with the numbers that I was supposed to find, that I got. I told you how, and I got the final answer. Now, as I told you, if you want to check the genuinity of this calculation, okay, directly I'm writing the answer here now to give me some space. 48.51. Okay, so I'm writing the reaction again. 48.51. Now if I do the same things like second reaction, I multiply with 6. So let's multiply the second reaction with 6. What will I get? Carbon solid plus 6 O2 gas gives 6 CO2 gas. Then third reaction, I multiply with 3. I get 3 H2 gas plus 3 O2 gas gives 3 H2O liquid. And the first reaction I multiply with -1 and add it 6 CO2 gas plus 3 H2O liquid gives C6H6 liquid plus 15/2 O2 gas. Now according to Hess's law, when I add them, okay guys, when I add them, what is going to be cancelled off? So can you see 3H2O gets cancelled by 3H2, 6 CO2 gets cancelled by 6 CO2. Okay. Okay, oxygen I didn't balance actually. So now oxygen is balanced. It was to be multiplied with a half here. Okay, now if I add them, even 6 and this goes by 15/2 O2. Okay, now what is left behind? 6 carbon plus 3 H2 gas gives C6H6. And can you see this is your equation 4? Is this your equation 4? Yes, this is my equation 4. So this proves the genuinity of the steps. This proves the genuinity of inspection method. Okay, if you want to try it once again or for one more, I will show you one more, and one question is for you. You have to solve it on your own. You can I'll show you this question for 2-3 minutes, but before that let's solve this numerical. So what are they saying here? I hope you would have noted down the previous steps. If not, you can pause your video and write down the steps if you want to write. Okay, next what we are going to do, 3 reactions are already given to us, so we'll make it fast. So we'll write CH3OH liquid plus 3/2 O2 gas gives CO2 gas plus 2H2O liquid. Delta H1 naught is equals to minus 726 kilojoule. Second, carbon solid plus O2 gas gives CO2 gas. Delta H2 naught is equals to minus 393 kilojoule. Third, H2 gas plus half O2 gas gives H2O liquid. Delta H3 naught equals to minus 286 kilojoule. And the fourth thing that we have to calculate, the standard enthalpy of formation of methanol. So methanol, if you see, how will it be formed? C gas plus half O2, sorry, C solid plus half O2 gas plus 2H2 gas gives CH3OH liquid delta H4 naught, which we don't know. So how did I tell you to proceed? So last question, do you remember, like, what were the methods we did? Same way we are going to do here. So we can write delta H4 naught is equals to, first let's see carbon. Carbon is in which reaction? Second reaction. Number of moles, okay, 2. Side, okay. Now comes oxygen. The problem with oxygen is in reaction 1 also, 2 also, 3 also. So which reaction should you take and which reaction should you leave? In such situation, guys, what we will do is, if any element or compound is coming in more than one reaction, you have to neglect that and it will automatically get adjusted. That I will show you, that it is getting automatically adjusted. This is the beauty of inspection method actually. Okay, H2 if I see, it's only coming in equation number 3. Side is okay, but number of moles is not okay, so I multiplied with 2. Okay, methanol is coming in equation 1. Side is okay, side is not okay, number of moles is okay, so I'll multiply it with -1. So what should I do? Equation 2, that is -393 plus equation 3 -286 into 2 plus equation 1 into -1, 726 into -1, answer in kilojoule. This is your final answer. Okay, so you can find it out. -393 minus 286 into 2, that is -572 plus 726 kilojoule. So 393,572. So we can write it as 726 minus 965 kilojoule. And that is how much? 965 minus 726, that is -239 kilojoule. So we have got the value as -239 kilojoule. Okay, now we'll recheck again, as in the previous case, whether our answer and the reactions are matching or not. So second reaction I'll write here. Now third reaction multiplied with 2. And first reaction into -1. Okay, so yeah, this will become 2O2, or we can write it as O2. Right, what can we write this as? O2 gas 2H2. Okay, now if you add it, what will you get here? I have cancelled off the terms which were coming as common on both the sides. So can I write from here? It is coming as carbon solid plus 2H2 gas. Now O2 plus O2 is 2O2 minus 3 by 2O2 can be written as half O2 gives CH3OH liquid. So again you can check, we are getting our equation number 4. In all the cases you will get equation 4, so you don't have to worry about that. But yes, as I told you, there are some places where you will not be able to use this method, so a little cautious you have to be while using this. Third question, guys, if I'm leaving you for you, like this would be the first question of my next video, so please pause this video, solve this question by the same method as I have told you, and please post your answers in the chat box. Answer in the comment. Okay, so please like and subscribe this video, share with your friends as much as you can for those whom you feel it would be helpful. Okay, and also let me know how was this video, how fruitful it was to understand this concept. Was my way of interaction okay, or what changes should I bring here? Examples will be discussed more if depending upon the topic. This topic is not that big, so I have just taken 2 questions. So next class, what we are going to do in next video, that is video number 3. Okay, we will start, we'll keep on doing inspection method. 2 more questions we'll do, and after that I'll tell you a very important basic concept of redox. So right now I am concentrating on class 11th only, then slowly we'll move on to organic chemistry and topics of grade 12th. So thank you for watching my video, guys. Have a great day. Bye bye.